All right, good morning. What I want to do is go over the third congruence or similarity between all the stuff that we've started talking about in chapter 4. So in the directions up here, it says what we're going to do is use the angle-angle postulate. We've learned that. We've learned side, side, side. And then the one I'm about to teach you is called side, angle, side. And we're going to use those postulates basically to prove that in each of these three problems that each pair of triangles is similar. That should not say congruent, that should say similar. Change that on your directions, please. So as we reviewed, angles can be congruent between similar triangles, but the sides would be proportional, not necessarily congruent. So what we're going to do here then is justify our answer by showing side ratios, which is where I divide out the sides that are corresponding to each other, and we can write out all the congruent angle measures. If they are similar, what I want to do is create a similarity statement, which says, like in this case, we would say triangle XYZ is congruent or is similar to triangle RST. And if the side lengths are given, which a couple of them are in this case, what we'll do is provide the scale factor from the large to the small triangle. So that just tells us how many times larger the larger one is than the small one. So what I want to do first here is see that I have these two sides that are given in each of the triangles, and we have an angle between them. So maybe make a note of this on the note side, that the angle between two given sides is called the included angle. And it's a vocabulary term, and what it basically means is this is the angle that is between these two sides that would be proportional, hopefully, to these two sides if these are similar triangles. So if you were to follow an order, this would be side, angle, side. So that's why we call it the side, angle, side postulate. So I'll quickly show you how to prove that these are or are not similar. So what I'm going to do first is take the corresponding sides, which in this case it looks like the 10 yards from XY is going to correspond to RS, which is 6. So I'm going to take 10 divided by 6, and I'm going to set that equal to, and I'm going to do my other two, which would be the 18 and the 10.8. So 18 divided by 10.8. And what I want to do is divide out each of these ratios. And what we're going to do is see if the two ratios are the same, then the two triangles are going to be proportional. So this one comes out to about 1.67. And if I divide the other one, 18 divided by 10.8, I also get 1.67. So since your ratios are equal, this right here is my scale factor, which means that that large triangle is 1.67 times larger than the small one. And what I want to do is state the congruent in similar parts here. So that'll be the next part. I'll do that in the bottom corner here. And we'll just state which things are similar to each other. So I'll make a proportion and say that if I take xy over, so we took xy right here, and we took it over 6, which is RS, that was proportional to when I took the 18, which was xz, over the RT 10.8. So that's what I would like to see as far as a proportion goes. Also state that the included angles are congruent, so you can say that angle X is congruent to angle R. And notice the difference in the notation here. This was talking about the side lengths being proportionally equal, and this is talking about the two angles being congruent. So at the very end, I can make a similarity statement, and I'm going to say triangle XYZ. So if we follow the order, I'm going from X, passing the shorter side to Y, and then going down to Z, and that would be similar, which is just one little dash like that, and that would be similar to RST. And I believe that answers everything. So I created a similarity statement, and I provided the scale factor, I gave the side ratios, and I gave my congruent angle measures. So that problem is done. These triangles are similar by side, angle, side, so I'll even write that below. That SAS, side, angle, side postulate means that these are similar. The next one, notice we're not giving angles, so this looks like it could be a case for side, side, side. So the first thing we would need to do is just prove basically that our ratios are proportional, or that the ratios themselves are congruent. So I'm going to take my shorter side of the bigger triangle first, so it looks like HG, and I want to see if that corresponds to the short side over here, which is KJ or JK. And then I'm going to take the medium length side, or the middle, which looks like and the bigger triangle, which looks like IH or HI, and I'm going to take that over KL. And then I'm going to look for the longest side that's in this triangle, which is IG. And I'm going to put that over the longest side of the small triangle, which is JL. And now we'll just start filling in our proportions with all of these measures. So I'm going to take HG, which is 7, over KJ, which is 3. And we're going to set that equal to HI, which is 10 feet, over KL, which is 5. And again, all I'm doing right now is filling in this giant proportion that I made before, just by filling in all these lengths. IG is the 12 right here, and JL was 6. So now what I'm going to do is divide these, and if these three numbers come out to the same ratio, that means these triangles are similar. So I'm going to take 7 divided by 3, and it looks like I get about 2.33. And I want to know if that is equal to 10 divided by 5, and you guys know 10 divided by 5 is 2, and 12 divided by 6 is 2. So I have that 2 of my ratios are similar, but this third one is not. So cross that off, and you could say that these triangles are not similar. And again, the reason being is that all three ratios would have to be congruent or equal in order for the two triangles to be similar. Since we don't have any angle measures here, we need all three sides to be proportional. Versus in the last example, we only needed 2 proportional sides because we had the included angle between them. And then the third example. Notice I'm not given an angle here, but that's kind of the design of this problem, is that you see that I have 2 intersecting lines here, and I have these 2 angles are created. Hopefully you guys are thinking, what's the relationship between the 2 of these angles, and that these are vertical angles, which means that they are congruent. So it looks like, if I'm looking at the top triangle, it looks like I have a side and then an angle and then a side, and down here I also have a side. I have the angle as being congruent, and I have another side. So we are going to try to prove that these triangles are similar using the side angle side postulate. So the first thing I'm going to do is try to create my side ratio by taking my shorter side, which on this drawing would be from E to C is 7.2. So I'll take EC over my short side, which is BC, and I'm going to set that equal to my longer side over here, which is CD, and I'm going to take that over AC. And what I'm going to do is just fill in these proportions then. So I'm going to take the length of EC, which is 7.2, and take it over BC, which is 6. And then I have CD, which is 9.6. And I'm going to take that over AC, which is 8. And like I said, we need to divide these out and make sure that each of these ratios gives us a number, and that number is the same between the 2 of them. That will tell us that these triangles are proportional. So, or similar. So this first one, if I take 7.2 divided by 6, I get 1.2. And if I take 9.6 divided by 8, I also get 1.2. So that means that 1.2 is our scale factor, meaning that this bottom triangle is 1.2 times larger than the top one. And then what I want to do is state the angle that is congruent between the 2 of these. So I'm going to do that all the way up top. Here, the angle that is congruent, so follow my lettering, angle ECD is referring to this bottom one. Angle ECD is congruent because of vertical angles to the angle above it, which is BCA. So now that I have 2 proportional sides and an angle between them that is congruent, I can say that these are similar by the side angle side postulate. So again, I gave my ratios, I showed my congruent angle between the 2 of them, and then I provided a scale factor, and I showed that it was side angle side congruence. So please finish the other side of this worksheet that has 3 very, 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 very similar problems. One of them might have to do with angle. So really read into that. If I'm not giving you sides, you can use only angles. So that is one of our older properties. And then once you guys are done, you'll just hand it into the basket in the back of the room. Thank you.